Hi and welcome to this video on conversion factors, maths made easy. Now conversion factors and proportions are used to convert say hours into minutes or the other way around. Map scales, converting sort of the dimensions on a map to real dimensions. They're also used for converting currencies and also used for scale maps and making models. In this question we want to convert 2.75 hours into minutes. We follow this procedure. First write out the units you have. So we've got 2.75 hours. So write this like this on this side, on the left hand side, 2.75 hours. Write out the units you want to end with. So we want to convert it into minutes. We want to end in minutes, so write that on this right hand side. Then we write the appropriate conversion factor. Now the appropriate conversion factor is either given to us or we should know it. So in this one we should know that 1 hour is 60 minutes. That's our conversion factor. Now which way round should we write this? Should we write 60 over 1 or 1 over 60 to get our conversion factor? We get this by looking at the units. The units are hours. So if we write this as a fraction or as fractions such as this, so 2.75 over 1, and then we try to work out which way round this should be. Should it be 60 over 1 or 1 over 60? If we look at these units, if we got them as fractions, we can cancel these units. We can cancel this hour with this hour and essentially be left with 2.7 times 60 minutes is 165 minutes. So we've cancelled the units, just been left with 2.75 multiplied by the minutes. That gives a total answer in minutes. Been asked to convert 2.75 hours into seconds. Let's follow the same rules. The units were given on the left hand side, 2.75 hours. What do we want our answer to be in? We want it to be in seconds, put that on the right hand side. And then our conversion factor, or factors in this case, because we want to convert first of all into minutes and then into seconds. So our first conversion factor is this one. Which way round? Look at where our units are. So hour on the bottom, we can cancel with the hour here. So write it this way round. We'll be left with minutes. So which way round should this conversion unit be? It should be 60 seconds over 1 minute. So then we can cancel this minute, this unit with this unit, and essentially we'll be left with 2.75 times 60 times 60 seconds gives us our answer in seconds. So the units have disappeared here, here, here and here. We're left with 2.75 times 60 times 60 seconds, 9,900 seconds. We've been asked to convert 4 meters to millimeters. We know there are 100 centimeters in 1 meter. Therefore, we know that there are 1,000 millimeters in 1 meter. So this is going to be our conversion unit. Write out our workings. So given units 4 meters on the left hand side. We want it in millimeters. That goes on the right hand side. Our conversion unit with the meters on the bottom so that we can cancel the meter as units and be left with 4 times or multiplied by 1,000 millimeter, and that gives us our answer as 4,000 millimeters. Here we're going to convert currencies. How many pounds do I get for 300 euros? We know that a pound is 1.17 euro and it fluctuates. What are we given? We're given 300 euros, so put that on our left hand side. want the answer in pounds, that goes on our right hand side. And then this conversion units, 1 and 1.75, which way round? So we've got this euro here, so we want this euro on the bottom of the fraction so that we can cancel the units, the euros out, and get our answer in pounds. So when we cancel the euros, 300 multiplied by 1 over 1.75 gives us our answer, 256.41 pounds. Conversion factors also used in map scales and ratios also. So we're going to work this out as ratios. First of all, let's see what they mean by 1 to 1,000 or 1 to 100,000. This means the real distance is 100,000 times the length of one unit on the map. So if we're told it's in centimeters, this 1 to 5,000 means that 1 centimeter on the map equals 50 meters in real life. So how do we get that? There's 100 centimeters in a meter, so we just cancel these first two zeros and we get the 150. We get the first, cancel the first two zeros and we get 50. So that's 50 meters. In this case, 1 to 10,000, again in centimeters. So 1 centimeter equals 10,000 centimeters in real life. So cancel the first two zeros and we're left with 100. So 1 centimeter equals 100 meters. In this case, 1 centimeter equals, cancel the first two zeros, 125 meters. Conversion, scale 1 centimeter to 1 meter. 1 centimeter to 1 meter is 1 centimeter to 100 centimeters, which is, as a scale, 1 to 100. So if somebody asks you to put this into a conversion, as this 1 to 100, that kind of conversion, do it this way, so you convert it into the same units, so into centimeters, and you get the conversion 1 to 100 conversion scale. Scale 5 millimeters to 1 meter, so 5 millimeters, we get the same units, equals 1,000 millimeters, 5 to 1,000. So simplifying that, we get 1 to 200. If the scale we're given is 5 centimeters to 2 kilometers, this is 5 centimeters to 200 meters, 5 centimeters to 200,000 centimeters. So we're converting the meters into centimeters, multiplying by 100, and then simplifying this, divide by 5 here, we get 1. Divide this by 5, we get 40,000. So the scale is 1 to 40,000. If a scale is 1 to a conversion factor here, say x, then we multiply the map distance by x to get the actual distance. So the scale, so this scale factor we're given is 5,000, so the scale is 1 to 5,000. And we're told that 8 centimeters on the map, what the item we're measuring, or whatever we're measuring, say the width of something or the length of something. What's the actual distance? So put it down this way as a ratio, 8 to A equals 1 to 5,000. So therefore A divided by 8 is, or equals 5,000 over 1, which is this ratio. So A equals 5,000 times 8. We're taking the 8 to the other side. When we divide here, we multiply if we take it to the other side of the equals. So A equals 5,000 multiplied by 8, which is 40,000 centimeters. Convert this into meters, divide by 100, which is cancelling these first two zeros, and we get 400 meters. Scale is 1 centimeter to 5 kilometers. What's the actual distance on the map if the actual distance is 14 kilometers? So the actual distance is 14 kilometers. and we want to scale that down to a map distance. So say a wall, or which would be quite a lot. Actually, it wouldn't be a wall that long. Say it was a road 14 kilometers long. What would be the map distance of that road? So write it down as this ratio: x to 14 equals 1 to 5. So we're keeping these units as we're given. We want the distance as centimeters. So keep the ratios as centimeters to kilometers. This is 1 to 5. This would be 14 to x. So x divided by 14 equals 1 divided by 5. That's our ratios. So 5x equals 14. We take the x to the left hand side, divide by 5, multiply if we're taking that onto the other side, equals 14. So divide by 5 here, we get x, divide by 5 here, we get 2.8 centimeters. So our map distance would be 2.8 centimeters. We can write it in this way if we want to remember it in an exam. The map distance equals the actual distance divided by the scale factor. So the actual distance we're given is 14 kilometers. The scale factor is 5, 1 to 5. So 14 divided by 5, 2.8 centimeters. We've told that a map has a scale of 1 to 50,000. Worked out that the area of a farm on the map is 6 centimeters squared. What's the actual area of the farm in hectares in real life? Well, if we think about it, we want to get a unit first and then work out 6 units. So the unit we're going to use is centimeters squared. So if we've got 1 centimeter squared and we've got this ratio 1 to 50,000, this side is going to be 500 meters. 1 to 50,000 in meters is 500 meters. So this side is going to be 500 meters. This side is going to be 500 meters. So 1 centimeter squared on the map is 500 meters times 500 meters in real life, which is 250,000 meters squared. So 500 times 500. Quickly check on that. 5 times 5 is 25, and 1, 2, 3, 4 zeros. 25, 1, 2, 3, 4 zeros. So that's right. So we've got that a centimeter square on the map is going to be this many meters squared. So we'll multiply that by 6 to get 6 centimeters squared. And that gives us this answer. 1, 5 with 1, 2, 3, 4, 5 zeros meters squared. We want the answer in hectares. So divide that by 10,000, 10,000, which is 1, 2, 3, 4 zeros less. So take away 4 zeros, 1, 2, 3, 4, leaves us with 150 hectares. A tennis court is 7 meters wide by 21 meters. And then we're making a plan or a scale drawing. And on our scale drawing, the court is 3.5 centimeters wide on our scale drawing. What's the length going to be? So we use proportions. So we get 7 is over 3.5. 7 divided by 3.5 is going to equal 21 over x. So 7 divided by 3.5 equals 21 over x. So x equals 21 divided by 2, 7 divided by 3.5 is 2. Take the 21 to the side, that becomes 21 divided by 2 equals x. So 21 divided by 2 equals 10.5. Here again, we're doing exchange rates, but we're going to convert euros into dollars. So first of all, we convert into pounds, then we convert into dollars. We need 2 conversion factors. Our first conversion factor, the euro, has got to be on the bottom of the fraction so that these euros cancel. On our second conversion factor, the pounds on the bottom, because we're left with this in pounds, and we want the units as pounds to cancel to leave our answer in dollars. So this is our first conversion factor, cancel the euros to be left with pounds. Our second conversion factor, cancel the units to be left with dollars. And our answer, 1 multiplied by 1 over 1.175 multiplied by 1 over 1.528. Our answer is going to be in this unit, dollars, because we've cancelled the other units out. So the answer is 0.556 US dollars. Converting 3 feet into meters, or 3 foot into meters. Again, 2 conversion factors. 1 inch is roughly 2.5 centimeters. 12 inches in 1 foot. First of all, convert the meters into feet. Convert the feet into inches. So this is the first conversion factor, foot on the bottom to go inches. And then we've got inches to centimeters because we want the answer in centimeters or meters. So use these 2 conversion factors. Remember which way round to put them so that these units cancel to give us our final in centimeters. We cancel this foot by this foot. Here left with inches, cancel this inch with this inch, left with centimeters. The answer is 90 centimeters or 0.9 meters. Always remember to give your answer in the units they want, so it's going to be 0.9 meters. What is 120 kilometers per hour as miles per hour? So again, the units we're given on the left hand side, 120 kilometers per hour over 1 hour. This conversion factor we get from knowing that 1 kilometer equals 0.6214 miles. So which way round? We want the kilometers on the bottom so that this cancels, the units cancel each other. And when we do that, when we cancel the units, we're left with 120 multiplied by 0.6214 miles per hour, which is 74.6 miles per hour. Dilution factors, we'll quickly go over this. Dilution factors used in chemistry and can also be used as a maths question, I suppose. So if you add 10 mils of a sample to 40 mils of water, this gives us a dilution factor of sample to diluent, or diluent can also be solvent, of 1 to 4. And this is expressed as a dilution factor of 1 to 5. So we've got 1 part of the sample and the total is 5. So that is called the dilution factor. A 4-fold dilution is the same thing as a quarter dilution. And in this example, if you had 1 mil of a solution of cells, so you got like so many cells in a 1 mil, and you performed a 1 in 2000 dilution. In the final solution, this diluted solution, you took out 1 mil, counted how many cells there were, and you found that there were 40 cells in that diluted solution. How many cells were there in the original solution, this 1 mil that you started off with? Well, all we have to do is multiply, not divide, multiply by this factor 2000, and we get that there are 80,000 cells in the original 1 mil solution. So in the original solution there are 80,000 cells per mil. Dilutions are used when you want to save on solvents, when you're diluting to a certain dilution factor. So for example, for 5-fold dilutions we add 1 mil of sample to 4 mil of solvent, take 1 mil of that we've made, that solution that we've made, that 1 mil to 4, and then add that to another 4 mil of solvent, and then take 1 mil of that and add it to another 4 mil of solvent. So our dilution factor then becomes 1 to 5, the next one 1 to 25, the next one 1 to 125, the next one 1 to 625, and then the next one 1 to 3,125. So that you see that we get this over 3,000 plus dilution using very little solvent. So this is like a serial dilution. So in this case, we'd have to use a lot of solvent if we wanted to make this 1 to 3,125. So we can put here, because we're doing these serial dilutions, we use very little solvent.